Okay, welcome back, kiddos. Now we are moving on to Unit 9. So I think you're going to find this one to be quite fun and a lot easier to understand maybe than the other stuff. So let's get right into it. So this is going to be, we're going to start with the Pythagorean theorem. So you have heard about the Pythagorean theorem before. Okay, so that's going to be our key word that we're going to discuss today. And that describes the relationship between the side lengths of a right triangle. So only when we're dealing with a right triangle. Okay, and so we know it's a right triangle when we see that right there, right? That's what tells us that it is a right triangle is when we see that box. Okay, so if triangle ABC is a right triangle, so ABC, right? We know that that's this triangle that they're talking about, with a right angle of C. So if C is that right angle, then A squared plus B squared equals C squared. So A and B, these are the ones that make that right angle, and these are going to be called legs. Those are called legs. Okay? A squared and B squared are called the legs. Okay? This one, which is across from the right angle, okay, so that one's called the hypotenuse. And that's always the longest side of a right triangle. It's always the longest side of a right triangle. Okay, that's called the hypotenuse. Okay, so we know if we just shot an arrow out, it goes like that. So on either side of that, those are called legs, and those are the ones that are a squared plus b squared equals c squared. If it's a right triangle, then this has to be true. Okay, so that's the main thing that we're going to be working with today. Okay, so keeping that in mind, we are going to use the Pythagorean theorem. So it says find the value of x. Okay, so we see this right triangle over here, and we want to find the value of x. So thinking about what we just talked about, see if you can set this up. Okay, so the first thing that we're going to do is we're going to label the hypotenuse. Okay, so we're going to label the hypotenuse, and we know that if this is the right angle, right, the hypotenuse is just going to be right across from it, right? So if we can imagine that we're shooting an arrow right over there. So this is going to be our hypotenuse. I'm going to just label that with a h, lowercase h. Okay, so that's x. So that's going to be, so if we have a squared plus b squared equals c squared, okay, so that's what is going to be the c squared, right? That's going to be the hypotenuse. So in order to solve for x, we're just going to set it up like this, and we're going to solve for x. Okay, so let's set it up. A squared is going to be 81 squared, right? Plus 108 squared equals the hypotenuse, which is x squared. Okay, so we're just using this basic setup right over here. A squared plus b squared equals c squared. Okay, so now that we have that, let's go and solve for x. Okay, so the first thing we're going to do is we're just going to type both of these into the calculator. Okay, so we can just type that into the calculator just like that. If we do that, that's going to give us the answer of 18,225. Okay, so that's all we're doing is just typing that into the calculator. Equals x squared. Okay, so now we want x, not x squared. So we need to do the opposite of squaring. So the opposite of squaring, I'm just going to change a different color over here. So if I have x squared, the opposite of squaring is taking the square root. Okay, so if I take the square root of the right side, to keep it equal, I also have to take the square root of the left side. So that means I have to do the square root over there. Okay, so then if I work with my variables first, the square root of x squared, okay, what happens is this square and the square root cancel each other out, right? So only thing that's left is just this x, right? So that's what I'm going to bring down is just x. Okay, so that's what happens when I take the square root of a square, it turns back into the original. Okay, so then the square root of 225, we're just going to type that into our Desmos, okay, just like that. If we type that into our Desmos, that will give us the answer of 135. Okay, so that's our answer, is x equals 135. That's how we figured out that length, because we knew it was a right triangle, so we labeled the hypotenuse. That's the way we knew which one went over here on the right side of the equal sign. Then we just solve for x. Okay? All right, next, let's go look at another one. Okay, so on this one right here, see if you can set this one up. Okay, so this one we recognize that one is our right angle, right? So this one is going to be our hypotenuse. 8 is going to be our hypotenuse, right? So if it's a squared plus b squared equals c squared, okay, we're going to first put the hypotenuse, right? So hypotenuse, we think, where does it go? Here, here, or here? It goes with the c, and we're not going to forget to square it, right? That's a key, is that we want to square it. Okay, so now we have to have the a squared. Okay, so I can put either one. So let's just say that one, the 4 is the a. So I'm going to say 4 squared. I'm not going to forget that. Plus, okay, the b squared. Okay, so that's just labeled as x. So that's what we need to solve for. Okay, so now let's just do the math. Okay, we're just going to work from left to right just like we normally do. Okay, if I put that into my calculator, okay, 4 squared will give me 16. Okay, plus x squared. Okay, just going from left to right. If I put that in my calculator, 8 squared gives me 64. Okay, so now think about what the next step is. Okay, if we're trying to get x squared by itself, remember we're going to take the square root at the very end. So we want to get rid of the 16, right? So the opposite of positive 16 is negative 16, right? So those cancel out. We're going to bring down the x squared equals, if I type that into my calculator, 64 minus 16, that's going to give you 48. Okay, so now if we just take the square root of both sides, right? So if I said I had x squared, I'm going to take the square root of that, right? And I have 48, I'm going to take the square root of that. Okay, so then if we just type that into our calculator, square root of 48 is going to be equal to, so x is approximately 6.928. Okay, x is approximately 6.928. So sometimes you don't get a whole number, okay? So because that's why this is an exact number, right? This is a decimal, okay? So this is our decimal answer, and then we could round that, okay? All right, so now let's take a look at one more example. Okay, so on this one right over here, see if you can set this one up. Okay, well, actually, first off, let me tell you that is a right triangle. Okay, so if I told you that's a right triangle, set it up. All right, well, let's go and label the hypotenuse, right? That one's the hypotenuse, right? We know that's a hypotenuse. So let's go ahead and put that, if we know it's a squared plus b squared equals c squared, right? We're going to put that over here, right? So we're going to say 3 square roots of 34, and we are going to square the whole thing. So that's how I'm going to do it. I'm going to put it in parentheses just like that. Okay, so now I need to do my a squared. So a is x, so I'm going to put x squared plus my b, which is 15, so 15 squared. Okay, so if you set it up like that, that's correct. That's good. At least you got that. So far, so good. All right, think about what would go next. Okay, well, if we go, we know we can put that into our calculator, right? So if I put this into my calculator just like that, okay, I'm going to make sure I put my square root symbol in and the parentheses. Okay, so that square root of, that squared is going to give you 306. Okay, and then 15 squared is going to give you 225, right? And then I keep working backwards, right? So now you may know what to do next, right? We're going to we need to get x squared by itself, so then we can take the square root, right? That'll be our last step. So we need to move that 225 by adding the opposite. So that means we're going to subtract 225 over there. Okay, that cancels out. So this one cancels out. We're going to bring down that x squared, right? Equals, and then if we put this into our calculator, right? 306 minus 225, that's going to give us 81. Okay, so now think about what would be the next step, right? If we had x squared equals 81, right? We would be taking the square root of that, right? Because we want it to get to x. So if I take the square root of, I want that to get to x. So if I want to take the square root of the left side, I also have to take the square root of the right side. That way, because it's balanced, to keep it equal. So the square root of x squared is x. Square root of 81, if we type that in, is 9. Okay, so even if we get a square root or anything like that, it's whatever is in there squared. So we're just going to make sure we put that in parentheses. So a squared plus b squared equals c squared. All right, so those are when we see those written out like that or given us those dimensions. So now let's do some word problems. All right, see if you can set this one up. Okay, so it says one of the legs of a right triangle is 9 and the other leg is 11. Find the hypotenuse. Okay, so let's just draw a picture, right? We know it's a right triangle, right? Because it says it's a right triangle right there. It says one of the legs is 9 and one of the legs is 11. So that would be like that's 9, that's 11, right? Because we know this is our hypotenuse. Okay, because that's right across from that. All right, so now they want us to find the measure of the hypotenuse. So let's just set that up, right? If that's 9, right, we remember it's a squared plus b squared equals c squared. Okay, so the a squared, a would be 9, right? So we would say 9 squared plus the b would be 11 squared equals, we'll just leave it as c squared, right? Because that's our hypotenuse. We always c is our hypotenuse. Okay, so then we are going to just going to put that into our calculator, right? I can put that right into Desmos just like that. If I did that, that's going to be 202, okay, equals c squared. Okay, so as we talked about, we are going to take the square root of both sides, right? So if I said c squared, I'm going to take the square root of that, and then I had 202, I'm going to take the square root of that. Okay, so if I do that, that's going to give me c is approximately 14.212. Okay, now this one says to the nearest tenth. Okay, so that means we are going to underline that 2. We're going to look to the 1, ask it what to do. It tells us to bring down the 2, and then we're going to work to the left. Okay, so that's our answer. It's approximately 14.2. All right, next, our last one. See if you can set this one up. All right, so this one tells us the hypotenuse of a right triangle is 15. One of the legs is 9. Find the measure of the other leg. Okay, so that's what we're trying to find. Maybe put a double line under what we're trying to find. Okay, so we know it's a right triangle. Okay, it says the hypotenuse is 15. So we know the hypotenuse is right over there. It says one of the legs is 9. Okay, find the length of the other leg. That means the other one is x, right? That's what we need to find is x. So let's just set it up, right? If it's a squared plus b squared equals c squared, let's start with the c squared. I always like starting with that. Okay, so the c squared is what, 9x or 15? So of course it is a 15, right? But not 15, it is 15 squared, right? So then we have 9 squared plus our x squared. Okay, so then if we put that into our calculator, 9 squared is 81, right? Plus x squared equals 15 squared is 225. Okay, so then we want to get x squared by itself, right? So we know we want to take the square root at the very end, right? So our next step is going to be subtracting 81 here. All right, if I subtract 81 there, I got to subtract 81 there. Those cancel out. I'm going to bring down the x squared equals 225 minus 81. Okay, so if I put that in my calculator, it's going to give me 144. Some of y'all may already know what the answer is on this, okay, because you know your squares and square roots. But that's okay if you don't, right? So we know that last step would be to take the square root, right? I'm going to take the square root of x squared. That means I have to also take the square root of 144. If I take the square root of x squared, that just gives me x, right? Because that cancels and that cancels. And then the square root of 144 is 12. Okay, so that's our answer. Okay, so that's all we're going to do is just make sure that we recognize which one is the hypotenuse. That's going to be our first step. Which one's the hypotenuse? Then if we know that, we're just going to put that for the c squared and then solve from there. All right, so make sure you do these practices before we move on to our next page. All right, so let's check this out, kiddos. All right, so now we're talking about using the converse. So we know the converse is going backwards. Right? Like a conversation. So if I'm told that a squared plus b squared equals c squared, okay, with a and b being like this and c being like that, that means it must be a right triangle. Okay, so this is the working backwards from what we did before, right? So before we said all right triangles are a squared plus b squared equals c squared. Now we're saying if we know it's a squared plus b squared equals c squared, then it must be a right triangle. Okay, so this is our practice on this. So it says, which one of these set of numbers could be three sides of a right triangle? Okay, so which one of these could be a right triangle? Okay, so we know it must be a squared plus b squared equals c squared if it's true. Okay, it has to be a squared plus b squared for it to be true. So here's what we're going to do. Say that, for instance, on this first one, this one would have to be the longest one, right? That would have to be if it was. So I'm going to ask myself, I'm going to say 49 squared, right? And I'm going to compare that to these two squared. Okay, so I'm going to say 30 squared plus 40 squared. Okay, so I'm going to put that in my calculator. So if I put 30 squared plus 40 squared into my calculator, if I put that into my calculator, right, so I would say 49 squared. So if I put that into my calculator, that would give me 2401, right? If I put these two into my calculator, 30 squared plus 40 squared, that's going to give me 2500, okay? So that does not equal, right? So that's what we're asking ourselves. Is it equal to it? It is not, so that one is false, right? But we're looking for true, so that one cannot be the answer. All right, so we would do each of those. So say we did this one right here. We would say 61 squared, because that wouldn't have to be the longest one, right? 61 squared. And we're going to compare it to 11 squared plus 60 squared, right? So if we did that, if we put that into our calculator, that's going to be 3721. And if we put 61 squared into our calculator, that's also going to be 3721. And so since that one is a true statement, that's going to be our final answer. This one right over here. Okay? All right, so that's what we're going to do. And so I have the solution right over here shows it. Okay, so as we talked about, if we did the 61 squared, it would give us 3721, and 11 squared plus the 60 squared would also give us 3721, right? The other ones would not give us those values. So we want to look at those to get a clearer understanding. So all those fail, right? There's only one that passes. Okay, so let's go ahead and take a look at our next problem. All right, so our next one, as you might imagine, this one is which one could not. So if it could not, it has to be false, right? So if we ask ourselves, is a squared plus b squared equals c squared, it has to be false, right? So it has to not equal. All right, so let's get into an example on that one. So we would compare all these, right? So say, for instance, on this one right over here. Okay, we would say 37 squared, because that one's the longest one, right? So 37 squared, and we'd compare it to these two, right? We would say 12 squared plus 35 squared, okay? And then we would ask ourselves, what is the relationship? Well, if we put those into our calculator, if we put 12 squared plus 35 squared into our calculator, it'd be 1369. If we put 37 squared into our calculator, that'd be 1369. So since that's equal to each other, that one is true, but we don't want true, we want false, right? So this one's not our answer, right? So we want the one that is not true. So if we went through all these, if we did 53 squared, right, and we compared that to these, so we said 29 squared plus 45 squared, okay? If we did that, these two would add up to 2866. This would calculate to 2809, and so since those are not true, that would be false, and that is our correct answer. This one right over here is our correct answer. Okay, because we want could not. All right, so that's what we're going to do. If we're going to see if it can or cannot form the sides of a right triangle, we're just going to compare it to the a squared plus b squared equals c squared. Okay, so now let's get into our last part of our practice. So make sure you do those on Delta Math. I know you'll find those quite easy. Now, this last part ties in just directly to what we did before. These are inequalities, right? This is an equation that's an equal. These are inequalities, right? So this one and this one, right? So this means greater than, right? And this one means less than. Okay, so if the c squared is equal to a squared plus b squared, it's a right triangle, just like this. Okay, but If the c squared, whatever that is greater than the a squared plus b squared, it's not a right triangle. It's an obtuse one, as you can see right here. Right, this angle right here is larger, so that would be an obtuse. Okay, and if the c squared is less, then that would be an acute one. Right, that would be an acute angle for C. This would be obtuse angle for C. This would be a right angle. So we can just tell if it's right, obtuse, or acute just by comparing those. So that's called the inequality theorem. All right, so let's get into a couple examples. All right, so this one right over here. So this is three sides of a triangle, okay, are 45, 30, 55, and 32. Use the Pythagorean theorem to determine if it's right, acute, or obtuse. That's what we want to find out. Okay, so let's take a look. This one has to be the longest, right? So let's compare. We're going to say 32 squared plus 45 squared. Okay, and we're going to compare that to 55 squared. Okay, so if we put that in our calculator, okay, the 55 squared is going to give us, that would give us 3025, right? And we're going to compare that to what this gives us. Okay, so if we brought that down, that would give us 3049. Okay, so what do we know? A squared plus b squared is what? Greater or less? It's more, right? So it is greater than the a squared plus b squared is greater than the c squared. So it's pointing to the c squared. Okay, so this points to c squared. Okay, so let's look at which one points to c squared. Okay, so this one points to a squared plus b squared. This one points to c squared. So when it points to c squared, that's acute. So this triangle is acute. Okay, because the square of the largest side, so this is the square of the largest side, is less than the squares of the other two sides, right? This is the square of the other, the sum of the squares of the other two sides, right? So the third side is less than the sum of the squares of the other side. Okay, so that means it's acute. Okay, so let's take a look at this other example. All right, so see if you can set this one up. Okay, so it says the sides of a triangle are 45, 42, 15, and 39. Use the Pythagorean theorem to determine is it right, acute, or obtuse. Okay, so which one is the longest? That would be the longest, right? So let's go and set it up. We would compare 42 squared, right? We're going to compare that to 15 squared plus 39 squared, right? So if we put that into our calculator, 15 squared plus that 39 squared, that's going to give us 1746, right? If we put that 42 squared into our calculator, that's going to give us 1764, right? So put the symbol the correct way. Which one should it point to? It points to the smaller value, right? If it points to the smaller value, it's going to be pointing that way, right? So if this is the c squared, right? If that's c squared, if that's a squared plus b squared, that means it's pointing to the a squared b squared plus b squared, right? So let's look. Which one's pointing to the a squared plus b squared? Okay. A squared plus b squared is pointing to that one. That's called obtuse. So that one is obtuse because the largest side, right? This is greater than, right? This c squared is greater than the sum of the squares of the other two sides. Greater than. Right? Another way of saying it is a squared plus b squared is less than c squared. Right? All right, so that's it. You got this.